This is Paul. So whoever's seeing this video, I hope you are doing well. In any case, I set up the information already. Whenever you're talking about a series being convergent, you want to set up a summation, or you could even use a limit in front of here. Some instructors will use that. So they put a dummy variable on top where the infinity is. I'll just use the infinity on top here. The absolutely part of absolute convergence means that we put an absolute value in the summand, or what we're taking the sum of. So you can see it. You can see it here. This is our setup. We'll always start at 1. We'll go to infinity. Okay. Now, if you notice in the numerator here, we have 2 to the n. So whenever we plug in a number, say 1, 2, 3, or 4, whatever it might be for n, 2n is always going to be even. Does that make sense? So if n equals 1, 2n equals 2. If n is equal to 2, the next number, then 2n is equal to 4. Notice it's even again. And you can see what's going on. I'm sure if you're asking this question, you're probably pretty good at math. Probably taking Calc 2 or an advanced Calc 1 class. Okay, so a -1 raised to an even power is always going to be +1. So that's where this +1 is coming from. Everything else is just a copy. The absolute value is a copy. The denominator and the summations are copies. Moving on to the next line, from here to here, we simply apply the absolute values. N is always going to be positive because we're starting at 1 and we're going to positive infinity. So there's no change. 1, of course, is a positive number, so there's no change. At this point, you should recognize the summation, or at least whenever you're taking your test. This is the harmonic series. If you start inputting numbers, you get 1, 1/2, 1/3, 1/4, and so on. So when you actually do take the test, you should know that this series diverges, which means that the original series is not absolutely convergent, is our ultimate conclusion. On a side note, suppose we were to alter the expression by putting a square in the n in the denominator, or really any power larger than 1. It would no longer be the harmonic series, but you could use p series, or the p-test, to decide whether it converges or diverges. I'll put that here. Long story short, if the power in the denominator is larger than 1, then we'll get it to converge. Since in our original expression, we get a power of 1, the series will not converge, that is, it will diverge. Okay, if you have any follow-up questions, feel free to contact me. My name is Paul. I hope you enjoy your day. Bye-bye.